This is the story of the solar system as you've never seen it before. A story told not through its planets, but through their incredible, and often violent, companions. We've spent centuries staring up at them. But we're only now discovering the truth. Moons are more than just dead rocks. They are active, dynamic, and diverse worlds in their own right. What if they, rather than the planets, are actually the most interesting worlds in our solar system? One holds the key to the birth of our own planet. Others are being slowly ripped apart by their parent worlds. And one, hiding under a shell of ice, may contain a secret ocean that might just harbor life. This is the moons of the solar system. For all of human history, we have had one constant companion: the moon. A silent, silver sentinel in the night sky. Before we knew what it was, we felt what it was. It was power. It was mystery. It was a god, a guide, a storyteller. Its steady cycle gave us our first calendars, a rhythm to plant, to hunt, and to live by. It pulled on the oceans, and it pulled on our imagination, weaving itself into the fabric of our myths and our religions. For millennia, we looked up and saw a perfect, ethereal, and unknowable world. A flawless pearl floating in the heavens. Then, in the turn of a single night, mythology began its slow surrender to science. In 1609, the Italian astronomer Galileo Galilei pointed a simple tube of wood and glass towards the moon and shattered our perception of the heavens forever. Where humanity had seen perfection, Galileo saw a landscape. It wasn't smooth. It wasn't ethereal. It was scarred and battered. It had mountains that cast long shadows and vast, dark plains he mistook for seas. And most importantly, it was covered in craters. The moon was not a perfect celestial spirit. It was a place, a world in its own right, with a violent and dramatic history written across its face. And the first chapter of that history was a story of unimaginable catastrophe. To understand the scars on the moon, we must travel back to a time before them, a time when our own Earth was still being forged. A molten, chaotic world in a dangerous and crowded solar system. It was not alone. Sharing its orbit was another young planet, a traveler on a catastrophic collision course. Science calls this world Theia. In Greek myth, she was the mother of the moon goddess. In planetary science, she is the architect of our world. For millions of years, Earth and Theia shared a similar path around the sun. But their dance was destined to end in a final, world-shattering embrace. The giant impact hypothesis is our leading theory for the moon's creation, and it is a story of almost incomprehensible violence. An entire world, the size of modern-day Mars, slamming into our own. The collision was not a glancing blow. It was planetary obliteration. Theia was destroyed instantly, The Earth, struck to its very core, was transformed into a seething, incandescent ball of magma and vaporized rock. The impact blasted a colossal fountain of material into orbit, a mix of Theia's shattered mantle and the vaporized crust of the young Earth. For a time, our planet would have looked like Saturn, surrounded by a brilliant, blazing ring of debris. But this ring was not destined to last. Gravity, the great sculptor of the cosmos, began to work its magic. Clump by clump, piece by piece, a new world began to coalesce from the ruins of the old. Over time, perhaps just a few centuries, the debris gathered into a single, massive sphere, a new celestial body born from the fiery crucible of two worlds. It was born a true companion, forged from the very same material as the Earth itself. But this violent birth was just the beginning. This new moon, now a permanent feature in Earth's sky, would go on to shape our planet's future in ways we are only just beginning to understand. It would become not just a partner, but a protector. So this new world was born, forged from the very body of our own. A sister world, hanging in our sky. But what was it truly? For centuries, it remained a mystery. A beautiful, scarred face with an unknown heart. The only way to find out what it was made of was to go there. The Apollo missions were more than a journey of discovery. They were a lunar excavation. For the first time, we could touch, analyze, and bring back pieces of another world.
From that date, a new perspective developed of man and his place in the scheme of things.
Apollo 8 coming to you live from the moon.
Apollo 8, history's first manned flight to the vicinity of another celestial body.
Astronauts brought back over 800 pounds of moon rocks. And they left behind instruments, seismometers, that would listen for moonquakes and reveal the secrets of its inner structure. Together, the rocks and the readings painted a remarkable portrait of a familiar, yet alien world. They revealed a world built like our own. A small, dense iron core at its heart. Above that, a vast, thick mantle. And finally, a rugged outer crust. The rocks told us this crust was made of two distinct terrains we can see from Earth. The bright, ancient highlands and the dark, younger plains of frozen lava we call Maria, or seas. Crucially, the chemistry of these rocks supported the story of its violent birth. They were strikingly similar to the rocks of Earth's own mantle, yet baked dry by the vacuum of space. The moon very much seemed to be bone and blood of the Earth. And with this intimate connection, this shared origin, the new moon began to exert its influence. In the aftermath of its creation, it was perhaps 10 times closer than it is today. This proximity forged a powerful bond. The young moon's gravity was so immense, it didn't just pull on Earth's oceans, it pulled on the planet itself, creating colossal tides of molten rock. This cosmic tug-of-war slowed the Earth's frantic, early rotation, lengthening our day from a mere 5 hours to the 24 we know now. But its greatest gift was not to our days, but to our seasons. A planet's tilt is what gives it seasons. But the gravitational pull of giant neighbors like Jupiter can make that tilt unstable, causing it to wobble wildly over eons. This is a recipe for climate chaos. A world thrown from catastrophic ice age to blistering heat. Our moon became Earth's anchor. Its steadying gravitational hand has kept our axial tilt locked in a stable, predictable range for billions of years. It is the silent guardian of our planet. This stability was a crucial prerequisite for life, allowing it the time it needed to take hold, to evolve, and to flourish in a reliable rhythm of seasons. It pulls our oceans, it marks our months, and it holds us steady in the chaos of the cosmos. The moon is not a passive observer. It is an active partner in our planet's story. It proves a fundamental truth we will see again and again on our journey. That to understand a planet, you must first understand its moons. And as we leave our home system, we will find this truth written in the most unexpected and dramatic ways. Beyond our familiar world, in the rusty embrace of Mars, two tiny moons, Phobos and Deimos, dance a different kind of ballet. These are not grand companions, but rather enigmatic fragments, whispers of the solar system's tumultuous youth. They are scarred and battered, their origins shrouded in mystery, and their fates uncertain. One spiraling ever closer to its doom, destined to shatter or crash into the red planet. The other drifting slowly away, a silent observer of Martian history. These are not worlds of oceans and atmospheres, but of rock and shadow, of questions and possibilities. These small moons were not observed until 1877, when astronomer Asaph Hall discovered them using the U.S. Naval Observatory's 26-inch telescope. These moons were named Phobos, meaning fear, and Deimos, meaning terror, after the sons of Ares, the Greek god of war, or Mars in Roman mythology, who were said to accompany their father into battle. The origin of these two moons has been a long-standing question. There are two main theories. One is that they were captured asteroids, pulled in by Mars's gravity. The other is that they formed from debris ejected from Mars after a large impact. The larger of Mars's two moons, Phobos, is a heavily cratered, irregularly shaped object, only about 27 kilometers across at its widest point. It is one of the darkest objects in our solar system due to its composition. It's thought to be made of carbonaceous material similar to some asteroids. These materials don't reflect much light, contributing to its dark appearance. Its surface is marked by a large impact crater named Stickney, which is so large that the impact that created it nearly shattered the moon altogether. What makes Phobos' orbit unique is that it is the closest moon to its planet in the entire solar system, orbiting a mere 6,000 kilometers above the Martian surface. It also orbits Mars incredibly fast, completing one orbit in just 7 hours and 39 minutes, much faster than Mars rotates. This causes Phobos to rise in the west and set in the east, appearing to move across the Martian sky 3 times a day. Even more unusual is that Phobos is gradually spiraling inwards, towards Mars, getting about 1.8 centimeters closer to the planet each year. In millions of years, it will either crash into the planet or be torn apart by Mars's gravity, potentially forming a ring around the planet. Deimos, the smaller of the two, is only about 15 kilometers across. In appearance, Deimos is even darker than Phobos, but appears smoother due to a thick layer of regolith. It orbits much farther from Mars than Phobos and takes about 30 hours to complete one orbit. Unlike Phobos, Deimos is moving slowly away from Mars and may eventually drift far enough to escape the planet's gravity altogether. And so, the story of Mars's moons is a tale of contrasting fates. Phobos, the personification of fear, rushes headlong towards its destruction, a fitting end for a moon named for panic and flight. Deimos, the embodiment of terror and dread, retreats slowly, fading into the distance, perhaps to wander the cosmos alone. In the end, the red planet, once attended by these two diminutive companions, may find itself solitary. A silent testament to the relentless and patient forces of gravity that shape the destiny of worlds. But our journey through the solar system's moons is far from over. We now turn our gaze to the gas giant Jupiter, a world that hosts a retinue of moons far more numerous and diverse than that of Mars. Among these, a special group stand out: the Galilean moons. These four moons, Io, Europa, Ganymede, and Callisto, are not just the largest of Jupiter's many satellites. They are worlds in their own right, each with a unique and fascinating story to tell. From Io's fiery volcanoes to Europa's hidden ocean, these moons offer us a glimpse into the incredible range of geological activity and potential habitability that can exist beyond our own Earth. Our story of the moons of Jupiter begins in 1610. The Italian astronomer Galileo Galilei points his newly improved telescope towards Jupiter. Night after night, he observes 4 points of light dancing around the planet, shifting their positions. He realizes these are not stars, but moons, the first ever discovered orbiting another planet. This monumental discovery shattered ancient beliefs about the cosmos and cemented the idea that Earth was not the center of all things. Closest to Jupiter, we find Io. A world of fire and brimstone. Io is the most volcanically active body in our solar system. Its surface is a chaotic tapestry of sulfurous plains, towering volcanoes, and lava lakes. It's thought that Io is home to over 400 of these highly active volcanoes, whose eruptions are triggered by a phenomenon known as tidal heating. Enormous friction is generated within Io's interior as it is pulled between the gravitational forces of Jupiter and the other Galilean moons, Europa, Ganymede, and Callisto. Io is caught in an epic gravitational tug-of-war. This immense exertion of force causes the moon's shifting interior to heat up, and dramatic eruptions cascade lava up and out. Io is in a constant cycle of rebirth, a world relentlessly sculpted by fire. Molten rock continuously burst forth from Io's volcanoes, renewing the surface of this fiery moon. Plumes of sulfur dioxide erupt hundreds of kilometers into the sky, painting the moon in vibrant yellows, oranges, and reds. Io's rare color is a stark and beautiful contrast against the blackness of space. To understand Io, you must imagine a world where the ground seems alive, constantly shifting and erupting. A world where fire dances across the landscape. While Galileo made the discovery of Io in 1610, it took until 1979 for its volcanic activity to be observed by Linda Morabito, an imaging scientist working on NASA's Voyager 1. Incredibly, Voyager 1 is still sending data back to Earth today, and it holds the record of being humanity's most distant object. You may notice Io's surface has a peculiar uniformity, in spite of its hundreds of volcanoes. The moon is constantly being resurfaced by volcanic activity, meaning it has very few impact craters. This makes it the youngest surface in our solar system, with its cycle of constant renewal filling any impact craters relatively quickly, in geological terms at least. The composition of Io is primarily silicate rock and iron, with its core made up mostly of iron. Above the surface, a thin atmosphere is dominated by sulfur dioxide. This atmosphere is so tenuous that it's about a billionth of the pressure of our own atmosphere here on Earth. Io's volcanic landscape is punctuated by vast lava lakes. Many of these lakes are found within depressions called paterae. These are volcanic indentations similar to calderas on Earth, but often far larger. These lakes of molten rock are constantly changing, with lava flows and eruptions altering their shape and size. Io's evolution is a constant one, the moon's landscape ever-changing. In essence, Io's lava lakes are windows into the moon's fiery interior, offering a glimpse into the powerful forces that shape this extraordinary world. Moving outwards from Io, the next Galilean moon we encounter is Europa. In stark contrast to the superheated Io, Europa's surface is dominated by ice. The landscape is a frozen kingdom, with deep fissures and cracks crisscrossing its surface. Europa's icy crust is estimated to be several kilometers thick. At 3,100 kilometers in diameter, Europa is slightly smaller than Earth's moon. This makes it the sixth largest moon in our solar system. A frozen behemoth, hiding fascinating secrets behind its frigid surface. Beneath this smooth, cracked landscape lies a vast ocean. The enormity of this cosmic body of water cannot be underestimated. In spite of Europa being about 1/4 the size of Earth, its oceans are thought to be twice the volume of all the seas and oceans on our home planet. Europa's icy shell is constantly being flexed and warmed by Jupiter's tidal forces, forces that mean the subsurface ocean remains liquid. Could this hidden ocean harbor life? The possibility tantalizes scientists. Geysers of water vapor have been detected by the Hubble Space Telescope, suggesting that plumes of water may be erupting from the icy crust, offering a glimpse into Europa's hidden depths. The same tidal forces that heat Io also affect Europa, though to a lesser extent. Hence, Europa's subsurface ocean remains liquid, while the surface of this moon is encased in thick ice. Europa has a very thin atmosphere, primarily composed of oxygen. This relative abundance of both oxygen and water fuels those theories that this moon might host that most elusive of phenomena: life. Europa's oxygen is believed to be produced by radiation from Jupiter's magnetic field, interacting with the moon's icy surface, splitting water molecules and releasing that precious, potentially life-supporting oxygen. While Europa is subjected to intense radiation from Jupiter's magnetic field, which could pose a challenge for any potential life, it's also possible that the subsurface ocean may be shielded from this radiation. We simply don't know, but what we do know is that Europa, more than almost any body within our solar system, possesses many of the characteristics needed to support life. One similarity between Io and Europa is that both moons have a relatively smooth surface, with very few impact craters. Why? The moons share a cycle of constant resurfacing. In Io's case, it's incredibly hot molten rock that's refreshing the moon's surface, while Europa's renewal is down to new ice forming, as the subsurface ocean's water burst through the fissures, the water freezing on the surface. Two separate ends of the temperature spectrum, one extremely hot and the other very cold, produce a similarly smooth surface on each moon. The reddish-brown lines that crisscross Europa are thought to be caused by mineral deposits that have been brought to the surface by this cryovolcanic activity. Europa, then, is a mineral, water, and oxygen-rich world. A world that tantalizes scientists with the possibilities held within. Beyond the icy enigma of Europa lies Ganymede, a giant amongst the moons of our neighboring planets. Indeed, when Galileo discovered Ganymede, he gazed upon the largest moon in our entire solar system, a moon that even dwarfs the planet Mercury in size. Ganymede presents a captivating blend of ancient and dynamic landscapes, hinting at a complex and evolving history. The surface of Ganymede is a rich and varied place, with distinct regions offering all kinds of immense geological features. We see vast, dark, heavily cratered areas, remnants of Ganymede's distant past, scarred by countless impacts over billions of years. This evidence of myriad collisions suggests that parts of Ganymede's surface are extremely old. A visual record of the brutal collisions that define the evolution of planets and their moons. Interspersed with these rugged, craterous regions are brighter, grooved landscapes, characterized by intricate networks of ridges, troughs, and faults. These grooved terrains suggest significant tectonic activity, periods where Ganymede's icy crust fractured and shifted, possibly driven by internal processes or tidal forces in its early history. Impact craters are present on both types of terrain, but are less dense on the grooved regions, supporting the theory that these regions are younger, having formed and reformed through tectonic movement and volcanism, erasing the moon's impact craters while other areas still bear the scars of those cosmic impacts. Perhaps most surprisingly for a moon, Ganymede possesses its own intrinsic magnetic field. This is a unique characteristic among moons in our solar system and suggests the presence of a molten, convecting iron core beneath its icy mantle. Like Jupiter's other Galilean moons, Ganymede is a world of variety and contrast. This internal iron dynamo generates a magnetosphere that deflects some of the charged particles from Jupiter's powerful magnetic field, creating auroras at Ganymede's poles, similar to Earth's northern and southern lights, though far more subtle. The iron core is encased in a rocky, mostly silicate mantle, which in turn is covered in an outer layer of water ice. Evidence suggests the presence of a subsurface ocean of salt water beneath this icy crust, possibly sandwiched between more layers of ice. Above Ganymede's frozen landscape, a thin, oxygen-rich atmosphere intrigues scientists with its potential to support life. Ganymede stands as a testament to the complex geological processes that can shape icy worlds. Its unique magnetic field, diverse terrains, and potential subsurface ocean make it a compelling target for future exploration, offering clues about the evolution of moons and even the potential for habitable environments beyond Earth. And so finally, orbiting furthest from Jupiter's grasp, lies a moon shrouded in mystery: Callisto. The fourth of Jupiter's Galilean moons, Callisto has its own unique character, distinct from its siblings, yet just as mysterious. It hangs in the darkness, a vast, pockmarked sphere nearly the size of the planet Mercury. A little smaller than its closest neighbor Ganymede, Callisto is nevertheless a giant amongst the moons of our solar system. Despite having been observed over 400 years ago, Callisto, like its fellow Galilean moons, is still revealing its secrets. Callisto doesn't boast the fiery volcanoes of Io, the potentially life-harboring ocean suspected beneath Europa's ice, or the complex terrain of Ganymede. Instead, Callisto offers something perhaps even more profound: a window into the dawn of our solar system. It is an ancient sentinel, a time capsule bearing the scars of billions of years. The moon's name, Callisto, recalls a nymph from Greek mythology pursued by the king of the gods, Jupiter. But how did this world come to be? Like Jupiter itself and other Galilean moons, Callisto was born from the primordial disk of gas and dust that swirled around our young sun over 4.5 billion years ago. As Jupiter grew, coalescing vast amounts of hydrogen and helium, a smaller, miniature version of that solar nebula formed around it. Within this circumplanetary disk, dust and ice particles collided, stuck together, and gradually grew into the moons we see today. Callisto, forming in the cooler outer reaches of this mini-system, coalesced more slowly, incorporating a rich mixture of primordial ice and rock. Unlike its inner siblings, which experienced more intense heat from Jupiter during formation and intense tidal forces since, Callisto seems to have had a gentler beginning. This likely prevented it from fully separating into distinct layers like a dense rocky core, a mantle, and a crust. Instead, Callisto is thought to be a more homogeneous blend, a vast sphere of roughly equal parts ice and rock, possibly concealing a small silicate core deep within. It is a less evolved world, a frozen relic preserving the conditions of its birth. It is a landscape utterly dominated by impacts, crater upon crater, overlapping, eroding each other over unimaginable timescales. Callisto holds the distinction of being one of the most heavily cratered bodies in the entire solar system. Its face is ancient, telling a story of relentless bombardment that characterized the early solar system. A violent era known as the Late Heavy Bombardment, when rogue asteroids and comets rained down upon the newly formed worlds. There are no vast volcanoes, no deep canyons carved by tectonic shifts, no evidence of the geological upheaval seen on the other moons. Callisto's surface has remained largely unchanged for billions of years. The only prominent features breaking the monotony of craters are colossal impact structures, ghosts of truly cataclysmic events. The largest, Valhalla, stretches nearly 4,000 kilometers across, about as wide as the landmass of Australia. And it's not a typical crater, but a multi-ring basin, like ripples frozen on a pond after a giant stone was thrown in. Another, Asgard, tells a similar tale of ancient planetary-scale violence. These immense scars are testament to impacts so powerful they fractured Callisto's icy crust, sending shockwaves propagating outwards, leaving behind these ethereal, concentric rings, monuments to a violent past. But beneath this ancient, frozen, seemingly dead surface, Callisto may hold a mysterious secret. Data gathered by Galileo spacecraft, which studied the Jovian system extensively, revealed anomalies in Callisto's interaction with Jupiter's powerful magnetic field. The best explanation? A hidden layer of electrically conductive material deep beneath the ice. Scientists believe this could be a vast, salty ocean of liquid water, over 100 kilometers thick, sandwiched between layers of ice, an ocean hidden from the sun, warmed perhaps by the slow decay of radioactive elements within its rocky component, or perhaps lingering heat from Callisto's formation. An ancient surface, a potential hidden ocean. What makes Callisto truly compelling is this combination of history and possibility. Its heavily cratered crust is a pristine record of our solar system's history. Its potential subsurface ocean adds it to the growing list of worlds beyond Earth that might harbor liquid water, a key ingredient for life as we know it. Being the furthest Galilean moon from Jupiter means Callisto experiences significantly lower levels of harmful radiation compared to its siblings. Another hint at the possibility of extraterrestrial life. These characteristics have led some to consider Callisto a potential future foothold for human exploration in the Jovian system, a possible site for a long-term base, a gateway to understanding the outer planets. Missions like ESA's Jupiter Icy Moons Explorer, JUICE, are set to perform detailed flybys, hoping to unlock more of Callisto's secrets. Callisto, the ancient sentinel. A world shaped by cosmic impacts, preserving the echoes of creation. A silent witness to billions of years of solar system evolution, potentially hiding an ocean of profound significance beneath its icy shell. It reminds us that even in the cold, dark expanses of space, wonder and discovery await. It is an invitation to look deeper, to explore further, and to never cease questioning our place within this vast, magnificent universe. The story of Callisto is still being written. A chapter in the epic saga of cosmic exploration. From the familiar cratered face of our own moon, born of ancient cataclysm, past the doomed dance of Phobos and Deimos around Mars, to the astonishing diversity within Jupiter's realm, Io's infernal fires, Europa's hidden ocean, Ganymede's magnetic heart, and Callisto's time-worn visage. Our journey has revealed worlds of staggering complexity and unexpected dynamism. We have witnessed surfaces scarred by primordial violence and surfaces constantly renewed by fire and ice. We have glimpsed landscapes preserving the dawn of the solar system, and others churning with geological fervor. Beneath frozen crusts, vast, dark oceans beckon, whispering hints of possibilities we are only beginning to comprehend. Yet these celestial wonders are but the first verses in a grander cosmic poem. Beyond Jupiter, Saturn awaits, with Titan's thick organic haze and Enceladus' startling geysers spraying ocean water directly into space. Undeniable proof of liquid realms beneath. The distant domains of Uranus and Neptune guard their own retinues of icy, enigmatic moons, archives of the outer solar system's deep history, largely unexplored. Hundreds of worlds orbiting worlds, each a potential key to understanding planetary evolution. The age of discovery is far from over. Each new mission, each returned signal, peels back another layer of profound mystery. Could life swim in Europa's sunless sea? What secrets lie frozen on Triton or buried beneath Titan's smog? The moons challenge us, inspire us, and hold answers to fundamental questions about the universe and our place within it. These are not mere points of light in the night sky. They are destinations. They are histories waiting to be read. They are potential habitats. The moons of the solar system represent the next great frontier. Vast, mysterious, and endlessly compelling, forever calling humanity outward to explore the infinite wonders of the cosmos. What if the most important worlds in our solar system aren't planets at all? What if I told you there's a moon with a thick, toxic atmosphere and rivers of liquid methane? A tiny world spraying a hidden, salty ocean directly into space. Or another, so violently shattered and rebuilt, it looks like a cosmic Frankenstein's monster. These are the moons of the outer solar system, and their stories are more bizarre than we ever imagined. Our first episode dealt with the familiar, a world born from a cataclysmic collision. We witnessed the stark fate of captured asteroids orbiting Mars. We then plunged into the realm of giants, and found a world of relentless fire and a sister moon hiding an impossible secret ocean beneath a shell of ice. But what lies beyond the grasp of Jupiter, in the vast, cold emptiness of the outer solar system? Here, the rules change. Here, we find moons that challenge our very definition of what a world can be. Our great cosmic tour now enters its final leg. We journey to the deep frontier. For centuries, Saturn was just a jewel in a telescope, a planet defined by its impossible rings. To early astronomers, it was a distant, silent monarch of the night sky. But they soon discovered this king was not alone. In 1655, the Dutch astronomer Christian Huygens pointed his telescope at Saturn and spotted a tiny companion, a single point of light he would name Lunar Saturni. This tiny companion would eventually be known as Titan, A few years later, the Italian astronomer Giovanni Cassini found 4 more, each a faint speck huddled close to the giant planet. For the next 300 years, that was the family portrait. A planet, its magnificent rings, and a handful of icy companions. But when our probing missions of the 20th and 21st centuries finally arrived, they shattered that quiet portrait forever. They revealed that Saturn doesn't have a handful of moons. As of our latest count, it has 274. This is a system of breathtaking scale and diversity. It begins with tiny moonlets, barely a kilometer across, embedded within the rings themselves, acting as shepherds, sculpting the ice around them. It extends out to the giants, worlds larger than planets, and then further still, to swarms of captured asteroids and comets in distant, looping orbits, ghostly prisoners of Saturn's immense gravity. 274 worlds, each with its own story and its own secrets. But to begin to understand the true wonder of this system, we must return to that very first discovery, the giant. The one that would change everything we thought we knew about where life could exist. We begin with Titan, a moon larger than the planet Mercury. The story of its birth is likely as grand as its scale. The leading theory is that Titan was not captured, but born right here. It formed from a vast, swirling disk of gas and dust that surrounded Saturn in its infancy, a miniature solar system in the making. Over millions of years, ice and rock in this disk clumped together, steadily growing into the giant we see today. It is a true child of Saturn. And as we approach, we encounter its single most defining feature. Titan is the only moon in our entire solar system wrapped in a thick, dense atmosphere. For years, what lay beneath this smog was a complete mystery. Unlocking its secrets required one of the most ambitious missions ever conceived. The idea began in the 1980s, a joint endeavor between NASA, the European Space Agency, and the Italian Space Agency. It was a project of immense scale and patience. After years of development, on October 15, 1997, the Cassini-Huygens spacecraft launched from Cape Canaveral, beginning a 7-year journey to the outer solar system. Its purpose was not just to visit, but to stay, to become a part of the Saturnian system and conduct an in-depth, long-term study of the entire kingdom. Cassini's objectives were vast: to analyze the planet's stormy atmosphere, to understand the dynamic, complex structure of its rings, and to characterize the geology and composition of its many, many moons. For 13 years, this robotic explorer would orbit Saturn, transforming our understanding. But for Titan, it had a secret weapon, a lander provided by the European Space Agency called Huygens. In 2005, after its long journey, Huygens plunged into the haze. For 2.5 hours, it fell through the nitrogen-rich smog. What would it find? A solid surface? An ocean of liquid? No one knew for sure. When the clouds parted, Huygens transmitted images that were both alien and eerily familiar. It had landed in what looked like a damp riverbed, surrounded by stones, made not of rock, but of solid water ice, frozen at minus 180 degrees Celsius. Using radar that could pierce the clouds, Cassini mapped the surface and confirmed the unbelievable. Titan has lakes, rivers, and seas. But this is not a world of water. On Titan, the rivers are filled with liquid methane and ethane. The mountains are sculpted from solid water ice, hard as granite. It rains gasoline from an orange sky. It is a twisted reflection of Earth. A complete hydrologic cycle, but with materials straight out of a science fiction novel. This atmosphere, rich in methane and nitrogen, is being bombarded by sunlight, creating a thick smog of complex organic chemicals called tholins. This is prebiotic chemistry on a planetary scale. It's too cold for life as we know it, but Titan is a planetary laboratory. It's like having a sample of the primordial Earth, perfectly preserved in a deep freeze. The question Titan poses is not, is there life here now? But, is this how life begins? For all its potential, Titan holds its secrets close. To find active liquid water, we had to look somewhere completely unexpected. Not to a giant moon, but to one of Saturn's smallest and brightest. The tiny, ice-white world of Enceladus. Its origins are a profound puzzle. Was this tiny world born in the same disk as its giant sibling Titan, a leftover from the system's initial formation? Or is its story more violent? Some scientists theorize that Enceladus could be the child of a cataclysm. A second-generation moon formed from the debris of a collision that shattered a larger, forgotten world billions of years ago. Its very existence is a cosmic mystery. As Cassini approached the small moon, scientists expected to find a quiet, frozen, dead world. Instead, what the satellite saw was shocking. Startling geysers erupting from the moon's south pole, spraying vast jets of ice and water vapor directly into space. This was cryovolcanism, ice volcanoes, on a scale no one thought possible. The discovery was so profound, the Cassini mission was redesigned. The craft was sent swooping directly through the plumes. And its instruments confirmed the source, a vast, global ocean of liquid salt water hiding beneath the ice. The tidal squeeze from Saturn's immense gravity keeps the core warm and the water from freezing solid. But Cassini found more than just water. It found salt, proving the ocean is in contact with a rocky core. It found microscopic grains of silica, evidence of hydrothermal vents on the sea floor. And most importantly, it found complex organic molecules. All the ingredients for life as we know it, liquid water, a source of energy, and organic chemistry, are being ejected into space, just waiting for us to sample them. This is our strongest link to the search for life that we started our journey with. Yet, the wonders of Saturn's kingdom don't stop there. The gas giant commands a court of at least 274 moons, a gallery of cosmic oddities that defies easy explanation. We start with Mimas. At first glance, it appears to be a battered relic, scarred by the colossal Herschel crater, giving it an uncanny resemblance to a science fiction battle station. The crater was named after William Herschel, one of the great astronomers of the 18th century. He discovered this moon, along with Enceladus, and most importantly, Uranus itself. For decades, it was dismissed as a dead, frozen artifact, but recent analysis of Cassini's data has revealed a stunning secret. The moon's slight wobble strongly suggests the presence of a vast liquid water ocean hiding just 20 to 30 kilometers beneath its cratered shell. Mimas is a stealth ocean world, masquerading as a simple lump of ice. Then, there is Iapetus, the yin and yang moon. Its surface is painted in a baffling contrast. One hemisphere as bright as snow, the other as dark as tar. Scientists believe this is the result of a runaway cycle, where dark material from space settles on its surface, absorbing heat and causing the underlying ice to turn to vapor, which then frosts the opposite side. Stranger still, the moon is girdled by a colossal mountain range along its equator, a 12-mile-high Great Wall of ice whose origins remain one of the system's greatest unsolved mysteries. As Saturn's grandeur recedes, we cross a new threshold of solitude. We follow the path of our sole visitor to this distant realm, Voyager 2. Everything we know about this system up close, every image and discovery, comes from a single, brief flyby in 1986. We are seeing what Voyager saw: a lonely ghost light, a pale ice giant journeying through the deep dark. This is Uranus. And as we draw close, it becomes clear it is a world that has turned its back on the rest of the solar system. Every other major planet in our solar system spins like a top as it orbits the sun. But Uranus is a top that has been knocked over. It lies on its side, with its poles pointed where the equator should be, rotating at an almost 98-degree angle to its orbit. The reason for this profound misalignment is believed to be a wound from a past trauma. Billions of years ago, during the chaotic formation of the solar system, it's thought that a wandering protoplanet, perhaps the size of Earth, delivered a glancing blow of unimaginable violence. This great cataclysm may be what tipped the entire world over. The moons of Uranus were either born from the debris of this collision, or were dragged along into their new, strange orientation. They don't circle their planet horizontally, but orbit it like a giant Ferris wheel. And this system has another peculiarity: a touch of human art in the deep dark. Unlike all the other moons in the solar system, named for gods and myths, these are the literary moons. They are drawn from the works of William Shakespeare and Alexander Pope. Names like Titania and Oberon, Ariel, Umbriel, and Miranda. It is a family of tragic and magical characters, a fitting choice for such a dramatic system. This drama is a long, drawn-out story. Orbiting the sun once every 84 years, it experiences extreme seasons. For 21 years, a pole on Uranus and its moons faces the constant, unrelenting gaze of the distant sun. A summer's day that lasts for 2 decades. This is followed by a winter of equal length. 21 years of absolute darkness and unimaginable cold. This shared trauma has forged a family of dark, strange worlds. And one of them wears the scars of that violent past more clearly than any other. This is Miranda. Named for the daughter of Prospero in Shakespeare's The Tempest, Miranda was the last moon of Uranus to be discovered, when she was observed in telescopic photos in 1948. When the Voyager 2 spacecraft flew up close to the moon in 1986, closer than any object it had encountered thus far, what scientists saw shocked them. Miranda is not a world. It is a scrapbook of worlds, a cosmic jigsaw puzzle whose pieces have been jammed together all wrong. It is the Frankenstein moon. Its surface is dominated by features seen nowhere else, called coronae. These are vast, trapezoidal regions of parallel ridges and valleys, etched into the surface with an almost artificial-looking precision. They look less like natural geology and more like cosmic scars, as if a giant claw scraped its way across the moon. But the most extreme feature on this tortured world is a single cliff, known as the Verona Rupees. It is the tallest, sheerest cliff face known to exist in the solar system. It stands at least 5 kilometers and perhaps as high as 20 kilometers tall. A precipice more than 10 times deeper than the Earth's Grand Canyon. Due to its height and Miranda's weak gravity, a fall from the top would last more than 10 minutes. A slow, silent descent into darkness. The sight of this jumbled world begs the question, what happened here? The first most dramatic theory was that Miranda met with a catastrophe. That a colossal impact shattered the moon to its very core. And what we see today is the result of those pieces, haphazardly falling back together, preserving the evidence of its own destruction. But another, perhaps more likely theory, suggests the violence came not from without, but from within. It posits that massive upwellings of warm, buoyant ice from Miranda's interior pushed upwards on the surface. These plumes would have stretched, cracked, and resurfaced huge areas of the crust, creating the bizarre coronae in a process of extreme cryotectonics. Whether it is a world reassembled from its own broken fragments, or a world torn apart by its own internal energy, the result is the same. Miranda is the ultimate example of the violent history of this sideways kingdom, a small moon that stands as a monument to chaos. But Miranda is not alone. It is the innermost of 5 major moons. Our first reconnaissance of this family was a game of orbital chance. Voyager 2's trajectory, designed to fling it onwards to Neptune, carried it just 29,000 kilometers from Miranda, giving us a breathtakingly clear view. But its other siblings were seen from much farther away. They remain ghostly portraits from a distant frontier, their secrets protected by distance and darkness. Farthest in, at a flyby distance of 127,000 kilometers, is Ariel, another moon named from The Tempest. Of all Miranda's siblings, It is the brightest and shows the most evidence of a geologically tormented past. Its surface is fractured by enormous fault systems, creating deep canyons. These valleys appear to have been flooded by icy cryolava, oozing up from the interior, creating smooth plains. Aerial hints that even in this cold, dark realm, a moon's internal engine can sputter to life. Next is Umbriel, which Voyager saw from more than twice as far away, a distance of 325,000 kilometers. At this range, our view is a frustrating muddle. It is the great enigma of the system, an ancient world that is uniformly dark, one of the least reflective bodies in the solar system. Why is it so bleak? What erased its geological history? We simply do not know. The only tantalizing clue on this otherwise featureless world is a single bright, shining ring on the floor of a crater called Wanda. We aren't sure what it is. It is thought to be frost deposits linked to an impact crater, but we cannot know for certain. Not until we are ready to send another probe deep into the solar system. Then there is the queen of the Uranian moons, Titania, seen from even farther out at 500,000 kilometers. Titania received its name from another Shakespeare character, the Queen of the Fairies in A Midsummer Night's Dream. As the largest, it bears scars appropriate for its royal status. Though our view is hazy, we can identify enormous canyons, like Messina Chasmata, that dwarf Earth's Grand Canyon. They are evidence of a past so violent, the moon's entire crust stretched and ripped itself apart. And guarding the edge of the system is Titania's husband, Oberon. Voyager 2 saw this world from over 500,000 kilometers away. A mere sketch. It appears to be the most ancient and heavily cratered, a relic largely unchanged for billions of years. Its mystery lies in what's inside its craters, floors covered in a dark, unknown material. Is it exotic ice, or carbon-rich sludge from the interior that erupted after impact? We simply do not know. 4 worlds, each a chapter in the story of this violent system, but with most of the pages left blank. Our fleeting glimpse from Voyager 2 gave us more questions than answers. Due to the extreme seasons, half of the moon's surfaces were shrouded in complete darkness, giving us only half of the picture. However, if we ever hope to see the full extent of these moons, we will need to send another probe to reach Uranus by 2050 during its equinox, when the system will be bathed in light. The clock is ticking if we are to unlock all of their secrets in our lifetime. Time may be running out to solve the mysteries of Uranus, but our original grand tour must press on. We make one final leap outward, across another 1.5 billion kilometers of silent, empty space. Here, the sun is just a bright star, its warmth almost entirely gone. We have arrived at the final planetary outpost, the last giant of our solar system, Neptune. Neptune is home to 16 known moons, but one of them dominates the system. A world so large and so strange, it presents us with our final great mystery. This is the realm of Triton, and it is a ghost story. To understand why, we must look at how it moves. With very few exceptions, every major moon in the solar system orbits its planet in the same direction that the planet spins. They are born from the same swirling disk and follow the same rules. But Triton is a rebel. It orbits Neptune backwards. This retrograde motion is what gives away its true past. It reveals that Triton is not a true-born child of Neptune. It is an intruder. The evidence overwhelmingly suggests that Triton was not born here, but out in the Kuiper Belt, the vast reservoir of icy bodies at the edge of the solar system. Millions of years ago, perhaps even billions, it wandered too close and was captured by Neptune's gravity. The event would have been cataclysmic, destroying any original moons Neptune possessed. Triton is a captured world from a distant realm, a ghost haunting a system it helped destroy. The violence of its past has given way to a deep, frozen calm. This is one of the coldest places in the solar system, but it is not dead. As Voyager 2 swept past, it saw one of the most unexpected sights of its entire journey. Geysers. Not of hot water, but of cold nitrogen frost. Driven by faint seasonal heating from the sun, pockets of nitrogen ice beneath the surface turn to gas, build up pressure, and erupt, shooting dark organic material kilometers high. It is a form of cryovolcanism unique to this strange, captured world, and its surface holds other mysteries. Huge regions of Triton are covered in what scientists call cantaloupe terrain, a wrinkled, pitted landscape seen nowhere else. Its origin is still debated, but it points to a complex geological history of upwelling ice and tectonic shifts. A captured world with a violent past. A world of nitrogen geysers and terrain that defies explanation. Triton was, for decades, our only up-close look at a large object from the far outskirts of the solar system. It is a visitor from the darkness, a lonely outpost that marks the end of our tour of the Great Moons, but the beginning of a new set of questions about the vast, unexplored territory that lies beyond. Because the story doesn't truly end at Neptune. Beyond it lies the third great zone of our solar system, the Kuiper Belt, the original home of Triton, and a realm of countless dwarf planets and icy relics. And here, we find that the relationship between planet and moon can be even more intimate. In 2015, our New Horizons spacecraft gave us our next glimpse of a Kuiper Belt native. The king of this realm, Pluto, and its giant moon, Charon. Charon is so close in size to Pluto, more than half its diameter, but they don't behave like a planet and its satellite. They are a true binary system, a planetary couple locked in a gravitational dance around a common point in empty space. Charon itself proved to be a complex world, with vast canyons and a strange reddish pole, reminding us that even in the deepest freeze of the solar system, moons hold incredible surprises. Hundreds of worlds, each with a story. From our own moon, born of cataclysm, to the moons of Mars, doomed to one day be destroyed. From the fires of Io to the ice of Europa. From the thick air of Titan to the sideways kingdom of Uranus and the ghostly plains of Triton. We have taken a grand tour of our solar system's moons and found they are not just points of light. They are destinations. We have learned that these worlds are richer and more dynamic than we ever dreamed. That the building blocks for life, liquid water, organic chemicals, and energy are not rare. They are everywhere, hidden in dark oceans and sprayed into space from tiny, unassuming moons. They are histories, and some, perhaps, are harbors. The age of discovery is far from over. It is just the beginning. As we speak, a new generation of explorers are being built. The next great mission to the outer moons is Dragonfly, a nuclear-powered, car-sized drone destined for the hazy skies of Titan. Scheduled to launch in July 2028, it will not be confined to one landing spot. It will fly through Titan's atmosphere, from one region to the next, sampling the surface and searching for the chemical signatures of life. We have found that our solar system is not just a collection of planets. It is an archipelago of countless worlds, each one a testament to the endless creativity of the cosmos. As we send our new explorers to the mists of Titan and beyond, we know that the greatest discoveries are still to come. The moons are calling, and humanity, as always, is destined to answer.